Now let's take a look at another problem in estimating a population mean. We're going to use problem number 15 on page 351. So the problem we're given is looking at whether or not garlic reduces cholesterol. So if you read through that paragraph, you're going to see that we have an N equals 49. We have 49 subjects in our study. These individuals were first having their cholesterol level measured, then they consumed raw garlic, and then they had their cholesterol level measured afterwards. And the value we're working with is the difference between those two scores on the cholesterol. So for each individual, their post-garlic consumption cholesterol score was subtracted from their pre-garlic cholesterol score. So that's what we're working with, is the difference here. We have a mean of that for 0.4. And our standard deviation for the sample is 21. So we're being asked to construct a 98% confidence interval of the mean net change in cholesterol, and we're going to take this a step further than our last problem because we're going to then apply that to a hypothesis testing to make an inference about the effectiveness of garlic in reducing cholesterol. So let's apply our flowchart and go through and look at making our decision regarding which distribution we're going to be using. So is our sigma known for this particular problem? Yes or no? Is the population normally distributed? Or do we have an N greater than 30? And based on your answer to these questions, are we using a distribution, a Z distribution or a T distribution table? Well, we do not know sigma. We're not aware of the normality of the distribution. That information is unknown, but we do have an N greater than 30, so that means we're going to be using our T distribution table. So, moving forward and applying our T distribution, we're going to move this time and do this over in Stats Crunch. So once you have your Stats Crunch open, you're going to go under Stat, select T-Stats, then one sample, and finally the one we're going to work with is with summary. So we're using summary statistics, such as we have here in the problem. Now keep in mind you also have the option at the one sample to select with data if you're working with a raw data set, as some of the homework problems have, where you have the raw data and you can click on the icon to open it up in the Stats Crunch. And there you'll be processing it by selecting the particular column of the data that you want to solve. So we're going to be working with the with summary. So if you go through those steps and open it up, you should be getting a dialog box similar to this one here. And here you can see I've already entered in the variables we're going to be working with. So our population, our sample mean of 0.4, our sample standard deviation of 21, and our sample size of 49. Now, make sure you're coming down and selecting the option for the confidence interval for mu. That's what we're solving for here. And here you can see that we're given the confidence interval of 98, so I've entered that in as 0.98. Once you have these information entered into your Stats Crunch summary, hit compute, and you should get an output that looks like this. Now let's go through and apply this output to solving our problem. So we're going to use this information to construct our 98% confidence interval by plugging our lower limit in as the left option. So mu is greater than our lower limit, and we also have mu then is less than our upper limit. So in this particular problem, as we go to move these numbers over, we need to pay attention to our rounding rule. So remember, if it's a full data set, then we can have one more decimal place in the data. If the problem is solved using summary statistics, we use the same decimal place as the stats. So which type of problem do we have here? Did we work with a full data set, or did we work with summary statistics? Well, we worked with summary statistics, so we want to keep our decimal place in the same location, the same level of decimal places as the summary stats that we were given. So we're going to go 1 decimal point. So we can see here that our 98% confidence interval is going to be negative 6.8 to 7.6. Now, let's move on to the last part of this problem, where we're being asked to make an assessment of whether or not the confidence interval suggests about the effectiveness of garlic in reducing the cholesterol. So here we can see this is a hypothesis testing question. And we can see that since the confidence interval includes a value of 0, it's very possible that the mean of changes in cholesterol equals 0, and this would suggest that there has no effect. So the value of 0, meaning 0 change in cholesterol level, resides between negative 6.8 and 7.6. So it is perfectly possible that the mean change in cholesterol level was 0, which would mean, of course, that there was no effect.